Okay, in this lesson we're going to continue to look at dot plots, but you're also going to see a new data display, and that data display is a histogram. But first, let's take a look at workbook page 323. The data below shows the number of hours a group of students spent doing homework last week. For number 1, we're going to draw a dot plot to represent the data, and we also must title our display. Now, if you remember, when we're talking about a dot plot, we need to have a number line. So I'm going to make a line here on this grid. And let's see, it looks like the smallest number is 0, and 8 is the biggest. So I have to go from 0 to 8. I'll just keep going. Okay, so there's my number line. And now every time I see a number, I'm going to put a dot above it. So for 5, I need to, let's see if I can get a dot here. There's my dot above 5. For 4, I need to make sure that I have a dot above 4. Let's see. And you get the idea. You can finish the rest of your dot plot. Just every single time you see a number, put a dot above it. You may also want to cross off every number that you've already put a dot in for. That way you don't do something twice or forget a number. Oh, and don't forget, we must title our display. So let's see. I might title this Hours Spent Doing Homework last week. Okay. When you're done with your dot plot, it's going to look something like this. Let's see. For number 2, how many students does your dot plot represent? Explain how you know that number of students is correct. Well, let's see. I'm seeing 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. I'm seeing 15 dots in my dot plot. And if you look at the data at the top of page 323, you're going to see that there's 15 numbers. So in this case, we must be talking about 15 students because there are 15 numbers in this set. Analyze. Why are there no dots shown at 2 and at 7? Well, obviously there's no students that spent 2 or 7 hours on homework. When you're making your dot plot, even though, some numbers might not have any data for them, you still want to make sure that your number line includes them. So it is okay to have gaps in your dot plot. Number 4, why do you think 5 hours is the most frequent number of hours? Explain. Well, I don't know. What do you think? Why do you think 5 is the most frequent? I'm thinking, 5 is somewhere in between, the 0 and the 8. It's kind of close to the middle part, so I might say 5 is close to the middle. So, we have some outliers. Outliers are the numbers that, seem a little big or seem a little small. They just look like they don't really belong with the rest of the data. And in this case, our outliers are 0 hours, even 1 hour. It's very rare to spend that little amount of time on homework. But then you also have the outlier of 8. It's rare to spend that much time on homework. So 5 is somewhere in between those outliers. Number 5, let's see here. The data represent 15 students. Would the scale of the plot change if it included more students? Explain. Well, I think the least time would probably stay the same, right? but the greatest time could potentially change. Maybe, you know, we interview or survey more students, more than 15 students, and maybe there's somebody out there who's done 9 hours of studying or 10 hours of homework. So I guess the greatest number could potentially change. All right, and the last one on this page, we're going to do some predicting. Suppose the data represents 6th grade students. Would the data change if it represented high school students? Explain. So I'm going to let you think about that. Do you think that the numbers of hours spent doing homework would change if we were interviewing high school students? Now, suppose you were suppose you were asked to make a data display that shows the age of every person in the United States. Do you think you'd want to make a dot plot for that? Do you think that would be a sensible choice? Think about that. Every single person in the United States. That would be a whole lot of dots. So instead of a dot plot, you may want to use a histogram. A histogram is a frequency display, just like dot plots display frequency. They show you how often something occurs. A histogram also is a frequency display, but it uses bars to show the distribution of data in a set, and the data are presented in intervals. An interval is a range of numbers. So if you look at the bottom of this histogram, those are your intervals. You have 14 and under, you have 15 to 24, you have 25 to 34, you have 35 to 44, and so on. A histogram is used when we want to graphically display a large set of data. The intervals are usually the same size. That's very important. They're usually the same size. And also, the bars touch. So all the data in the set are included. So this is different than a bar graph. A lot of people think that this is a bar graph, and that's not the case. A bar graph does not have intervals, and a bar graph does not have bars that touch. Usually the bars are separated. Height and width are two important characteristics of the bars. The vertical height, which you know is the y-axis of a bar, shows the frequency. So over here we have the frequency, how much it occurs. And the horizontal width, the x-axis, shows the intervals, which we said was down here. That's how the data is all grouped. So we're going to use this bar graph to answer some questions. Okay. Look at the bottom, number 9. Which age group has the least number of people? So in this case, you want to look at the intervals because those are your age groups. Age groups are down here. It looks like the least number of people is the 75 and over group. Which age groups have nearly the same number of people? Let's see. I would say the 15 to 24, the 25 to 34, and probably the 45 to 54. Those are all really close. What age group has about 15 million people? So now we have to look at the frequencies, which are over here. Which one is close to about 15 million people? So it's somewhere between the 10 and the 20 million on that left side there. So I'm guessing that would probably be the, that looks like the 65 to 74 age group. About how many people are 14 and under or 75 and older? So let's see, 14 and under. Let me use a different color. Here's the 14 and under, right here. And that looks like it's at about 60 million. And then the 75 and older, that's right here. That looks like it's about 10 million. So if I put those together, because it says 14 and under or 75 and older, so I got to combine those, that's about 70 million people that are in those age groups. So if you think about it, it makes sense that there's a lot of younger people, and then the numbers start to decrease as you get older, because obviously as you get older, more people are going to pass away. Now, let's discuss. Where do you think a person that is 34 and a half would be included in this graph? 34 and a half. So if you're 34 and a half, you are right in the middle. Oops, let's do a different color. I'm feeling blue. Here we go. So 34 and a half, you're right in the middle of those two age groups. Do you think you would be included in the 25 to 34 range? Would you be included in the 35 to 44 range? You decide. Now the last part is making a histogram. Now this is tricky because now you have to come up with the intervals, and sometimes that is the hardest part, is coming up with the intervals. Remember, for the intervals you need to make sure that they're equally spaced. Equally spaced intervals. So the ranges of your numbers are going to be the same. I want you to take a minute and think about what a good set of intervals would be. It looks like our lowest number here for the length of miles would be 45. So 45 is the lowest. And our greatest is, I think it's the 410 here. So those are the greatest distances in miles of these different rivers. What intervals might you use for the bottom of your histogram? Remember that they must be equally spaced. Okay. I'm leaning towards the intervals of maybe 1 to 100, and then maybe 101 to 200, and then maybe 201 to 300, and you get the idea, 301 to 400, and 401, oops, let me fix that. Alright, 401 to 500. And you'll notice for all of those intervals, they are equally spaced. If you do 100 minus 1, you're going to get your 99. If you do 200 minus 101, you're going to get 99. If you do 300 minus 201, you're going to get 99. All of those intervals are equally spaced because they all have a range of 99 numbers. Remember, for range you subtract the highest and the lowest numbers, and if you don't remember, we're going to review that anyway. But they are all equally spaced. And then for our frequency on the other side, so this is the length in miles. And then on the other side we have the number of rivers. So we have 1 river, 2 rivers, 3 rivers, 4, 5, 6, you got it. So what you're going to do is you're going to graph some of these. Let's see here. It looks like for the 1 to 100 range, let's see, let me just erase these so we don't have those. 1 to 100 would be 45, 90, 97. Looks like we have 3. 3 in the 1 to 100 area. And now let's do 101 to 200. So that would be 129 here. And the 169 over here. So there's 2. And I'm doing different colors. You do not have to do that. And let's see. How about the 201 to 300? That would be the 287, the 285, and the 273. So it looks like there's 3 there. And you get the idea. You can complete the rest of your histogram. And now for our takeaways. Remember, a frequency display that uses bars and that has intervals, that's a histogram. So it must have, this is so very important, you might want to highlight this, it it must have an interval or intervals, and it must have bars, and they should also be touching and equally spaced intervals. Okay. Oh, I have that over here. Okay, and in an interval, it must have a range of numbers, and sometimes, I haven't really heard it called this, but remember, an interval could also be called a bin. So if they ever talk about a bin in your workbook, you know what they're referring to.